यस, सो लास्ट टाइम हमने कुछ एमसीक्यूज ऑलरेडी सॉल्व किए थे, तो आज के लेक्चर में हम कुछ और एमसीक्यूज सॉल्व करते हैं। यस, आई होप यू कैन सी द स्क्रीन। Okay, so I've just gone through these MCQs. I think 4 to 5 MCQs हमने सॉल्व किए थे ऑलरेडी। Yes, 6. See this 7th one. ये भी शायद हुआ था ना। Let us see the next question, which is of the same type once again, which we have already solved. The charge on condenser having the capacity of 5 microfarad. ओके, 5 माइक्रोफैराड वाले कैपेसिटर के ऊपर का चार्ज हमको ढूंढ के निकालना है। Yes, we already solved this. Okay, let us go to the next question. That is, the two identical capacitors are connected as shown in the figure. A dielectric slab is introduced between the plates of one of the capacitors so as to fill the gap. The battery remaining connected. Okay, तो बैटरी हमने कनेक्टेड रखा है और एक कैपेसिटर के दो प्लेट्स के बीच में हमने एक डाइलेक्ट्रिक स्लैब डाल दिया है, so that the gap will be filled. The charge on each capacitor will be, yes. So let us crop this question first and take it on your board. Okay, so let us read the question once again carefully. Yes, two identical capacitors. So both of these capacitors are same in area, in the distance between them, and everything is same. Okay, तो ये दोनों कैपेसिटेंस है। अभी ये देखो, अगर बैटरी को कनेक्ट करके रखा और हमने अगर नीचे वाले कैपेसिटर के दो प्लेट्स के बीच में अगर ये डाइलेक्ट्रिक स्लैब, ये जो डाइलेक्ट्रिक स्लैब दिख रहा है हमको, वो अगर इसके अंदर इंसर्ट कर दिया, डाल दिया अंदर, तो ऐसे हालत में what will be the charge on each capacitor? So what that is we want to find out, and no doubt, don't worry, the charge on each capacitor will actually be the same, just because they are connected in series with each other, and that's why the charge on each of them will be the same. That is we want to find out. Yes, सबसे पहली बात ये हमको समझनी है कि when this dielectric constant K का डाइलेक्ट्रिक स्लैब जब यहाँ पे इस सेकेंड वाले कैपेसिटर के अंदर डाल दिया जाता है, तो its capacity just becomes K times of original one. If we assume that the original capacity was C and C, suppose दोनों का कैपेसिटी पहले C था, तो उसको हम बोलेंगे ओरिजिनल कैपेसिटी C. लेकिन अभी यहाँ पे जब जैसे हमने ये कैपेसिटेंस यहाँ पे डाल दिया, मतलब डाइलेक्ट्रिक यहाँ पे डाल दिया, तो इसका जो कैपेसिटी है वो K टाइम्स बढ़ जाएगा, and its capacity will become K times of C, like this. And because of that, the total capacity of series combination here will actually be given by the formula 1 upon CS, which is going to be 1 upon C1 plus 1 upon C2, where C1 and C2 are C and Kc respectively. So we can just have this as 1 upon CS, which is equal to यहाँ पे K से मल्टीप्लाई डिवाइड कर देंगे तो यहाँ पे हमको मिल जाएगा K plus 1 upon Kc, correct है? And if we just take the reciprocal on both sides, then we can be able to obtain this capacitance of series combination here, which is actually going to be Kc upon K plus 1, correct है? So this is the effective capacity. Okay, so ये हो गया capacitance, new capacitance. Now we can just have the charge on this capacitor. तो अभी चार्ज निकालने के लिए ये जो 2 वोल्ट का जो बैटरी उसके साथ लगा हुआ है, तो उसकी वजह से वो कितना चार्ज खींचेगा, तो वो हमको अगर चाहिए, that means effective circuit of this now will become like this. There is a battery of 2 volt which is connected across a single capacitor whose value is CS, which is obtained here. Okay, तो CS इतने वैल्यू का है कि कैपेसिटर यहाँ पे लगा हुआ है. तो ऐसे केस में जितना भी बैटरी होता है और जितना भी कैपेसिटेंस होता है, इन तीनों के बीच में क्या रिलेशनशिप होता है तो हमको पता है. Q is equal to CS into V is going to be here. So the total charge on this whole combination is actually going to be Kc upon K plus 1 into V, which is 2 here, जो कि पोटेंशियल डिफरेंस है इस बैटरी का जो दिया हुआ है ऑलरेडी. तो वो अगर हमने यहाँ पे डाल दिया तो हमको मिलेगा फाइनली चार्ज ऑन द ईच कैपेसिटर will actually be ओके. अभी इसमें हमको इसको रिलेट करना है ओरिजिनल चार्ज के साथ. ओके, तो उसके लिए हमको ये सोचना पड़ेगा कि व्हेन द कैपेसिटर ये डायरेक्टरी व्हेन द डायरेक्टरी इज नॉट इंसर्टेड इन दिस प्लेट्स of the second capacitor here, at that time the charge on each capacitor was Q naught actually. So we want to express this Q naught, this final expression in terms of Q naught here. ये final expression तो हमको मिल चुका है, but we want to express it in terms of Q naught. So how will you relate it with Q naught is, तो देखो अभी अगर suppose initial condition जो है वो अगर consider करो तो उस समय फर्स्ट वाले कैपेसिटर का कैपेसिटी तो C ही था, लेकिन सेकेंड वाले कैपेसिटर का कैपेसिटी भी C था, जिसकी वजह से जो इफेक्टिव कैपेसिटी जो है तो वो पहले कितना था, C/2 था. ये समझ सकते हो आराम से. In that case the initial original capacity, effective capacity of both of these capacitors combined together was C/2, and hence Q naught, that is the charge on each capacitor, that means on the combination, would be equal to C/2 multiplied by this 2V, that is the potential difference, which is going to be 2 only. So if we just cancel out this 2 here, then we can just get that this Q naught is actually going to be same as C. And if we just put the value of this C as Q naught here, then we can be able to get the total charge on the combination to be simply equal to K into Q naught into 2 upon K plus 1, which gives 2K Q naught. Okay, if we just divide this whole thing by K, the numerator and denominator both are divided by K, then we can be able to get that Q is equal to K into Q naught into 2, and this whole thing divided by K here, that is to be divided by this K plus 1, and that is again to be divided by K only. तो K से डिवाइड कर दिया हमने न्यूमरेटर डिनोमिनेटर दोनों को, तो इससे सिंपली यहाँ पे कैंसिल हो जाएगा और हमको मिलेगा 2Q naught in the numerator, and in the denominator it will be 1 plus 1 upon K, which is going to be there in the option 1 here. Okay, so this is actually going to be the correct option. Just see, let's check. Yes. Wait. Q naught actually C by 2 into 2. 2 cancel, okay, C बचेगा. So Q naught was C actually. Actually, this first option must be the correct one, not the second here. Okay. उनके हिसाब से अगर देखा जाए तो भी अगर यहाँ पे ये सी इफेक्टिव का जो वैल्यू है वो अगर यहाँ पे रख दो तो वी का वैल्यू तो 2 है ना, तो उसकी वजह से वो तो 2 तो अपीयर करेगा ही वहाँ पे, और उसकी वजह से वो सेकंड ऑप्शन करेक्ट होगा. ये फर्स्ट ऑप्शन करेक्ट होगा, ना कि सेकंड. Okay, just see the next one. The circuit diagram given below, the value of potential difference across the plates of capacitor are. Okay. There must be some mistake. Actually, ये 13 किलो वोल्ट है और ये 12 वोल्ट सिर्फ, ऐसा तो नहीं हो सकता. दोनों या तो किलो वोल्ट में होंगे या तो फिर दोनों वोल्ट में होंगे. यस, दोनों किलो वोल्ट में है. ठीक है. So just make a correction here. Both of these potential differences are going to be there in volt, kilovolt actually. Okay. So, and we want to find out the total potential difference across the plates of capacitor. Yes. तो एक बात समझो यहाँ पे ठीक से, we can just draw a equivalent circuit of this. इसका एक equivalent circuit हम यहाँ पे draw कर सकते हैं जिसमें ये जो दोनों potential differences है, ये 12 वोल्ट का और ये 12 किलो वोल्ट का और ये 13.13 किलो वोल्ट का. ओके, ये दोनों सेम डायरेक्शन में करंट सेंड कर रहे हैं. This also and this also tries to send the current in the same direction. So their EMFs will just actually get added up together, and that's why we can just say that the total effective potential difference here in the circuit is going to be of 25 kilovolt here. Okay, and this is connected to the capacitors which are going to be there in series like this. So इसका जो इक्विवेलेंट सर्किट है, और एक इक्विवेलेंट सर्किट यहाँ पे हम दिखा सकते हैं यहाँ पे, जिसमें ये 25 किलो वोल्ट का जो बैटरी है वो हम यहाँ पे लगा देंगे, और ये दोनों कैपेसिटर्स जो है वो एक के बाद एक इस तरह से सीरीज में लगा सकते हैं इस तरह से. तो 25 किलो वोल्ट potential difference is applied across the two capacitors whose capacities are like 3 microfarad and 7 microfarad respectively. So in this case, the potential of 25 kilovolt will just get distributed in the inverse ratio of their capacities. We already have seen that when the capacitors are connected in series, the charge remains constant, right? Charge is going to be the constant, and that's why since charge is constant, V is inversely proportional to C. That means the potential V1 is to V2 is actually going to be C2 is to C1. And that means V1 is to V2 is going to be C2 is 7 and C1 is 3. So 7 is to 3 is ratio में हमको इसको बांटना है. But the total potential is 25. So 25 kilovolt has to be put or divided in two parts whose ratio is going to be 7 is to 3, which can be done easily. The first part will be actually 7 by 10 times of 25. And the second part can be like 3 by 10 into 25 again. So that we can just get this first part to be simply equal to 7 into 5 by 2. So matlab 35 by 2. Okay, so that means it will be 17.5, correct? And here it will be 3 5s of 15, 15 by 2, which is nothing but 7.5 simply. Okay, so 7.5. So, and both of them are going to be in kilovolt only. So you can just select this 17.5 kilovolt and 7.5 kilovolt as a correct option, which is available in option number 1 here. Okay, let us check. Yes. Okay. Let us see the next question. The equivalent capacitance of this infinite network ओके तो ये पूरा जो इनफाइनाइट नेटवर्क है कैपेसिटेंस का उसका हमको इक्विवेलेंट कैपेसिटेंस ढूंढ के निकालना है. इसका मतलब ये हुआ कि ये जो कैपेसिटेंस है all these capacitances are of same value of 1 microfarad each. Okay, so if we just see carefully here, then ये जो है इसके आगे हम सेम वैसा ही ब्रांच यहाँ पे लगा सकते हैं. बिल्कुल यहाँ पे और एक कैपेसिटर होगा, यहाँ पे एक कैपेसिटर यहाँ पे जुड़ा हुआ होगा और यहाँ पे और एक कैपेसिटर जुड़ सकता है. Again we can just consider there is one capacitor like this and one another capacitor here, and there is another capacitor like this here. That means this chain is endless. We can just continue this up to any number of times, infinite number of times like this. ये जो चेन है ये रिपीट कर सकते हैं हम कितने भी टाइम. तो ऐसे केस में देखो अभी अगर ये पूरा इनफाइनाइट चेन है तो इसमें से अगर हम एक कोई भी अगर पार्ट, ये वाला जो पार्ट है देखो ठीक से डी और ई वाला जो पार्ट है, तो वो अगर हम निकाल देंगे इसमें से, अगर हटा देंगे ये वाला पार्ट, अगर हम डिटैच कर देंगे तो उससे कोई फर्क नहीं पड़ना चाहिए. लेकिन अगर ये पूरे कैपेसिटेंस का जो वैल्यू है, ये पूरा जो ये इफेक्टिव कैपेसिटर है, ये पूरे सिस्टम का जो भी इफेक्टिव कैपेसिटेंस है उसको अगर हम सपोज सी बोल देते हैं सी, तो अगर उसमें से हमने ये वाला जो पार्ट है वो अगर डिटैच कर दिया और अगर ये बचा हुआ जो पार्ट मिलता है डी और ई के बीच में जो पार्ट हम देख सकते हैं यहाँ पे, देखो यहाँ पे सपोज ये डी और ई के बीच में का जो पार्ट है उसका जो कैपेसिटेंस इक्विवेलेंट कैपेसिटेंस बनेगा इंक्लूडिंग ऑल दिस इनफाइनाइट कैपेसिटेंस हियर, सो दैट मस्ट आल्सो बी सेम एज सी ओनली. करेक्ट है, तो ये भी सी होना चाहिए, तो जो कि हमको निकालना है एक्चुअली. तो अगर हम ये डी और ई के बीच में का जो कैपेसिटेंस है तो उसको अगर हम सी बोल देते हैं और ए और बी के बीच में का जो कैपेसिटेंस है उसको भी अगर सी बोल देते हैं तो उससे हमारा क्वेश्चन जो है वो सॉल्व हो जाएगा. देखो ठीक से, सो वी कैन जस्ट ड्रॉ एन इक्विवेलेंट सर्किट ऑफ दिस. इसका इक्विवेलेंट सर्किट हम कैसे ड्रॉ कर सकते हैं, देखो याद रखो डी और ई के बीच में जो इक्विवेलेंट कैपेसिटेंस है वो सी है, जबकि ए और बी के बीच में जो इक्विवेलेंट कैपेसिटेंस है वो भी सी है. तो ये सपोज ए है हमारा, ये सपोज बी है, और लेट अस ड्रॉ द इक्विवेलेंट सर्किट ऑफ दिस. सो यहाँ पे सबसे पहले ये कैपेसिटर लगेगा, सेम सेम सर्किट हम यहाँ पे ड्रॉ कर रहे हैं। Okay, this is going to be the point B here, and there are 3 capacitors. Which are, one is connected at this point here, one is here, and one is here, like this. So we can just draw them here. This is a capacitor of 1 microfarad. Here it is 1 microfarad, and here also it is a 1 microfarad capacitor. Okay, all these are kept as it is, but here from this point onwards, the point D is there, right? So here we can just consider this as a point D here, and this will be the point E here. Okay, तो अब देखो D और E के बीच में जो कैपेसिटेंस है तो वो C है, जो कि इक्विवेलेंट कैपेसिटेंस है ये पूरे कॉम्बिनेशन का, ठीक है, इंक्लूडिंग इनफाइनाइट कैपेसिटेंसेस। और A और B के बीच में जो इक्विवेलेंट कैपेसिटेंस है वो भी C ही है। तो अगर ये C है और ये वाला कैपेसिटेंस 1 माइक्रोफैराड का है, ये भी 1 माइक्रोफैराड का है, और ये भी 1 का है, तो ये पूरा सॉल्व करने के बाद हमको एक इक्वेशन मिलता है। देखो ठीक से, क्योंकि अभी सबसे पहले हम ये देख सकते हैं कि ये कैपेसिटर और ये कैपेसिटर, ये दोनों जो है वो एक्चुअली पैरेलल में बन रहे हैं, पैरेलल में है। तो पैरेलल कॉम्बिनेशन के कैपेसिटेंस हमेशा ऐड होते हैं, तो इसलिए इसका जो इक्विवेलेंट सर्किट बनेगा वो कुछ इस प्रकार से बनेगा, जिसमें ये पॉइंट ए और बी अपनी जगह पे रहेंगे, और यहाँ पे एक कैपेसिटर जो कि 1 माइक्रोफैराड का रहेगा। इसके बाद यहाँ पे भी एक 1 माइक्रोफैराड का कैपेसिटर लगा हुआ रहेगा, एंड यहाँ पे जो है तो एक ही कैपेसिटर लग जाएगा जो कि C+1 वैल्यू का होगा, समझ सकते हो ठीक से। ये C+1 वैल्यू का सिंगल कैपेसिटर, और ये 1 वैल्यू का कैपेसिटर, और ये 1 माइक्रोफैराड का कैपेसिटर एज इट इज हियर। Okay, if now we consider the series combination of all these 3 capacitances and consider the equivalent capacitance across A and B to be C only, then we can just say that this 1 upon CS is going to be equal to 1 upon this capacitor, which is 1 here, plus 1 upon this another one, which is C plus 1 here, and this third one is going to be again 1 upon 1. Okay, and now if we just try to solve this equation, then just remember that this CS is also going to be same as C only, because ये जो पूरा infinite chain है, इस पूरे सिस्टम का जो इक्विवेलेंट कैपेसिटेंस है वो हमने C एज्यूम करके रखा था, और आर्ग्यूमेंट ये था कि इसमें से अगर एक अगर पार्ट हटा देते हैं, इतना वाला पार्ट अगर हटा देते हैं, तो जो बाकी बचेगा उसका कैपेसिटेंस भी C रहेगा। उसकी वजह से हमने इस पूरे को C एज्यूम किया था, और वो यहाँ पे हमको यूज करना है, तो CS के बदले भी हमको C ही यूज करना है। सो अगर इस इक्वेशन को और सिंप्लीफाई करते हैं तो 1 upon C becomes equal to 1 plus 1 plus 1 upon C plus 1 as it is, and then we can just get that this 1 upon C is going to be equal to 2 plus 1 upon C plus 1, and hence in the next step we can just get that if we just transfer this 1 upon C plus 1 in that side, then we can get it as 1 upon C minus 1 upon C plus 1 is going to be equal to 2. So if we just cross multiply it here, then we can get that C plus 1 minus C upon C into C plus 1 is actually going to be 2. So that this C gets cancelled, and we'll be left with simply 1 upon C into C plus 1 is going to be 2, which means 2C into C plus 1 is equal to 1 means if we just open the bracket, then we can get this 2c square plus 2c minus 1 is equal to 0, which is a quadratic equation which can be solved by using the formula only. So if we just use a formula, then we can be able to get that formula, which is x is equal to minus b plus or minus root of b square minus 4ac upon 2a. ओके, ये वाला फॉर्मूला हमको यूज करना है जो क्वाड्रेटिक इक्वेशंस का रूट्स निकालने के लिए यूज किया जाता है. तो हमको मिलेगा यहाँ पे c is equal to minus of 2 plus or minus root of b square, which is 2 square, which is 4, minus 4ac. That means 4 into a, which is 2, and c, which is minus 1. That is to be whole divided by 2 into 2, matlab 4. Okay, so c can be written to be minus 2 plus or minus, here in the square root sign, we can just have this 4 plus 8, which is actually going to be 12, right? And that is to be divided by 4 as it is. So that we can just be able to get in the next step, 12 jo hai, root 12 can be written as 2 root 3, right? So minus 2 plus minus 2 root 3 upon 4. So that this 2 can be taken common and just be able to cancel it, so that we can just be able to get that. अगर 2 को कॉमन ले लेंगे और कैंसिल कर देंगे तो हमको मिलेगा minus 1 plus or minus root 3 upon 2. But as we can just see that this minus 1 minus root 3 upon 2 will be negative, which does not make any sense. So what we have to be left is we have to consider the plus sign only. So therefore plus sign अगर consider करेंगे तो हमको मिलेगा root 3 minus 1. Okay, root 3 minus 1 upon 2, which is there in this option 3 here, microfarad. Okay, so the answer is root 3, not plus 1. Actually, it should be minus 1 only. Yes. See here, the same equation we are going to get here. Yes, 2x squared plus 2x minus 1, which gives us the two values of capacitance, that is root 2 times of 1 plus or minus root 3 upon 2. We cannot make it as root 3 plus or minus 1 upon 2, but we can only select one option, that is root 3 minus 1 upon 2. Okay, which is there in option 3. So let us take the next question. V naught is the potential at origin in an electric field, which is given by E bar is equal to Ex into I bar minus Ey into J bar. The potential at the point x comma y is going to be. So that means we want to find out the potential at the point whose coordinates are x comma y in the electric field, which is given by Ex I bar minus Ey J bar. Okay, already we have done this last time. We have already seen that the technique to solve this is the relationship between the potential difference and intensity. So potential difference and intensity is related with this equation. V minus V naught is going to be integration of minus of E bar dot dr bar. करेक्ट है, ये रिलेशनशिप हमारे पास है, ये हमको यूज करना है यहाँ पे. तो अगर हम यूज करेंगे इधर तो हमको मिलेगा V minus V naught, where V is going to be the potential at this point x comma y, which we want here, and V naught is going to be the potential at origin. Okay, so origin पे potential V naught है, जो कि ऑलरेडी वहाँ पे दिया हुआ ही है, राइट, वी नॉट करके ही दिया हुआ है. एंड दिस विल बी एक्चुअली इक्वल टू माइनस ऑफ इंटीग्रेशन ऑफ ई बार, वेयर ई बार इज नथिंग बट ex into I bar minus ey into j bar, and that is going to be multiplied with dr bar, where dr bar is nothing but, we know already that it is dx into I bar plus dy into j bar. And this integration is to be carried out from origin, that is 0 0, up to the point which coordinates x comma y. Okay, so if you just work this out, then v minus v naught comes out to be simply equal to minus as it is. And if we just open this bracket, that means if we just carry out this dot product here, so dot product में हमको पता है already कि ex just get multiplied with the I bar only, sorry, dx only, and ey just gets multiplied with dy here, and this is to be integrated again from 0 0 to xy, no doubt. Okay, so in the next step, you can just have this v minus v naught to be simply equal to integration of ex dx. ठीक है, यहाँ पे दो टर्म्स यहाँ पे ओपन करने पड़ेंगे हमको. फर्स्ट टर्म विल एक्चुअली बी इंटीग्रेशन ऑफ ex into dx minus, here it will be minus of minus plus, and will be integration of ey into dy. So that we can just take this ex as a constant and it can be taken out. So we can just have this as ex into integration of dx will be simply x plus this integration of ey. Ey is a constant, and integration of dy will be simply y. But not to forget that we have to integrate it from 0 0 to x comma y. So don't forget to put the limits here. But it's okay. It's a coincidence here that when we put the limits, then we can just get that here. If we just put x in place of x, then we can get x only. And minus, if we just put 0 in place of x, we can just get 0. So that x minus 0 becomes 0 only. No, sorry, x only. And here ey kept as it is. And here also we can just get in the numerator. If we just put y in place of y, then we can get y. And 0 in place of y, then we can get 0. And after all, y minus 0 becomes y only. So we can just get this minus of ex into x plus ey into y. And this is going to be the difference in potentials at xy and origin. But since we want to find out the potential at point xy, we can just transfer this v naught in that side. So that we can just get this v simply. So v is going to be v naught plus minus x into ex plus y into ey, which is already there in this option 1. It should be the correct option. Okay, v naught minus x ex plus y ey. Yes, let us check. Yes. So the next question. Okay, in this given arrangement of capacitors, one 3 microfarad capacitor has got, okay, has got 600 microjoules of energy. ओके ये जो एक 3 माइक्रोफैराड का कैपेसिटर जो है उसके अंदर 6 माइक्रोजूल्स ऑफ एनर्जी stored है. Then the potential difference across 2 microfarad capacitor is going to be. That means we want to find out the potential difference across the 2 microfarad capacitor, and it is given that this 3 microfarad capacitor has the energy of 600 microjoules. Okay, see here. Make sure that all these 3 capacitors of 3 microfarad are just going to be in series, right? So series combination के अंदर क्या होता है ना, charge remains the same, right? Charge remains the same, and potential just get divided. So potential get added together. Yes, so we can just try to find out the. Okay, one more thing is that if suppose number of capacitors are connected in series, then the energy stored in all capacitance will just get added together so as to get the total energy stored in the combination. And even in case of parallel combination also, the total energy is going to be the sum of all, right? So here we can just see that this 3 microfarad capacitor, if it stores 600 microjoules of energy, then this 3 microfarad capacitor will also store the same amount of energy, and this will also store the same amount of energy, correct? And because of that, we can just say that the total energy stored in all these 3 capacitors combined together will actually be 3 times of 600. That means it will be 1800 microjoules. Okay, so if just we can just have these 3 capacitors combined together in a single one like this, and these two also combined together so as to form a single one, then we can just get that 1800 joules of energy will be stored in this combination, and the capacity of this combination will actually be 1 microfarad, which is clear from the series combination because these 3 capacitors are of equal magnitude and they are connected in series. So in series combination, if all these 3 capacitors are equal, then the effective capacitance will actually be 1/3 of each. That means 1 microfarad here in this way. Okay, so once we get this capacity and energy, we can just make use of the formula, that is half CV square. The stored energy stored in any capacitor is always going to be equal to half of C into V square, correct है? तो अगर हम ये यूज करेंगे तो इसमें से हमको क्या मिलेगा, देखो ठीक से इसमें से हमको V मिल सकता है क्योंकि हमको सॉरी ये माइक्रो जूल है. Yes, this is the energy actually. Okay, तो ये कॉम्बिनेशन के अंदर का एनर्जी जो है तो उसको अगर हमने डाल दिया 1800, don't forget that it is going to be in microjoules. So माइक्रो के बदले सिर्फ हम म्यू लिख देंगे, चलेगा? मतलब 10⁻⁻⁶. Imagine going to be equal to half of C, where C is going to be 1 microfarad. So we can just get that this 1 and simply micro मतलब 10⁻⁶, and V square is to be found out. So this micro will just get cancelled with this micro, and if we just transfer these two in that side, then we can be able to get this 3600 is going to be equal to V square, right? And V square equal to 3600 matlab V must be equal to 60 volt, correct? So the total voltage in the combination is going to be 60 volt. But since these two branches are going to be in parallel, that means here in this branch also the potential difference must be 60 volt only. And once we get the potential difference across this whole combination, इस पूरे combination के अंदर का potential difference हमको मिल गया है. Now we can just able to find out the voltage across each of these capacitors very easily just by using the potential divider formula, which already we have learned in the theory. So since in case of the series combination, the charge is going to be the constant. So since charge is constant, we can say that the potential difference is going to be inversely proportional to the capacitance. And hence we can just say that this V1 is to V2 is actually going to be equal to C2 upon C1, right? And then we can just get that. And C2 upon C1 kitna hai? So देखो, C1 is going to be 6 microfarad and C2 is going to be 2 microfarad. So the ratio of capacities is 6:2. मतलब वो बन गया 2:6. So 2:6 मतलब वो बन गया 1:3, right? And V1 upon V2 जो है वो 1:3 अगर है, but the total potential difference is 60 volt, which has to be divided into two parts, which are in the ratio of 1:3, right? So 60 को अगर हम 1:3 parts में divide करेंगे, तो first part कितना मिलेगा हमको? V1 कितना मिलेगा? तो V1 can be found out 1/4 into 60, right? And in the same way, V2, that means the voltage across the second capacitor of this 2 microfarad here can be obtained to be simply 3/4 times of 60 again. Yes. And that means we can just understand that is 4 15s are. So this will be actually 15 volt. Okay. At the same time, V2 is actually going to be 15 3s are. That means 45 volt. That's all. That's all. We have found out. So 2 microfarad capacitor के across का potential difference कितना है? 45 volt, जो कि यहाँ पे fourth option में present है, and that is going to be the correct option. Yes. ओके, इट्स ओके. उन्होंने थोड़ा अलग मेथड से किया है. हाफ CV स्क्वायर, एक कैपेसिटर का उन्होंने एनर्जी यूज किया है जो कि हाफ CV स्क्वायर इक्वल टू 600 माइक्रोजूल्स के साथ इक्वेट किया, और उसमें C के बदले 3 माइक्रोफैराड डाल दिया और V निकालने के लिए ट्राई किया, तो V मिला 60 वोल्ट. तो उसकी वजह से फिर ये एक कैपेसिटर के अक्रॉस अगर वोल्टेज 20 वोल्ट है, तो तीनों कैपेसिटेंस का वोल्टेज मिला के 60 वोल्ट बन जाएगा. वही तो हमने भी निकाला ना, 60 वोल्ट को तो हमको भी मिला था. और उसके बाद फिर एक 2 माइक्रोफैराड के अक्रॉस का जो पोटेंशियल डिफरेंस है, तो वो निकालने के लिए फिर से पोटेंशियल डिवाइडर फॉर्मूला ही यहाँ पे भी यूज किया हुआ है, दिख रहा है, जो कि 45 वोल्ट हमको मिल रहा है. दैट इज प्रेजेंट इन द ऑप्शन 4. करेक्ट है ना? यस. Let's see the next one. In the given arrangement of capacitors, 6 microcoulomb charge is added to the point A here. Okay, so इस A point पे हमने 6 microcoulomb का charge add कर दिया है. The charge on the upper capacitor is, yes. So let us take this question on our board. Understand the meaning of this earthing here. Earthing का मतलब क्या होता है कि जो भी चार्ज इस कैपेसिटर के ऊपर आएगा, तो उसका अपोजिट चार्ज जो है वो इस दूसरे प्लेट के ऊपर फॉर्म हो जाएगा, बिकॉज अर्थ इज is connected to zero potential, so which will be act as a source or sink also at the same time. So excess charge will just run away to the earth. ये हमको समझना है. तो अगर सपोज यहाँ पे A पॉइंट पे अगर हमने 6 माइक्रोकूलम का चार्ज अगर ऐड कर दिया, तो यहाँ पे A पॉइंट पे हमने 6 माइक्रोकूलम का चार्ज हमने ऐड कर दिया, ठीक है. तो उससे क्या होगा देखो, ठीक से we can just consider this earthing to be made up of a single line, single terminal, so that if we just try to draw the effective circuit of this whole combination, तो इसका अगर हमने effective circuit draw करने के लिए अगर ट्राई किया, तो वो कुछ इस तरह से बनेगा, जिसमें ये पॉइंट और ये पॉइंट, ये तीनों पॉइंट्स हम कंबाइन कर सकते हैं. That means if we just see this point is A here, and there is a capacitor of 3 coulomb, sorry 3C here, एंड इसके बाद वो अर्थिंग में, ये अर्थिंग है यहाँ पे, ठीक है. Yes, then again A is connected to a capacitor of capacity 2C also, and this another terminal of this 2C is going to be earthed, and एक का ही तीसरा और एक टर्मिनल जो है वो एक तीसरे कैपेसिटर के साथ जुड़ा हुआ है जिसका वैल्यू सिंपली C है, और उसका भी दूसरा टर्मिनल हमने अर्थ करके रखा हुआ है. ओके, तो इसका मतलब ये अर्थ किया हुआ जो टर्मिनल है वो कनेक्टेड है एक तरह से, ऐसा भी हम समझ सकते हैं. दिस होल ग्राउंड इज गोइंग टू बी कनेक्टेड, एंड बिकॉज ऑफ दैट वी कैन जस्ट हैव दैट if suppose a 6 microcoulomb charge is suddenly put on this point A here, then it will just get distributed but not uniformly. But अब देखो यहाँ पे एक समझना है हमको कि इस पॉइंट A का जो भी पोटेंशियल होगा और इस अर्थ का जो भी पोटेंशियल है, तो that is the potential difference between those 2 points is going to be the same. That means we can just consider that all these 3 capacitors are going to be there in parallel, right? And in parallel combination V is going to be constant. Parallel combination में क्या होता है, potential difference in each of the capacitors is going to be constant, and since V is constant, we can say that this Q is just proportional to C. The charge will just get divided in proportion to the capacities. That means here the charge of 6 microcoulomb here is getting divided in 3 parts whose ratio is going to be 2:3:1, correct? So if we try to divide this 6 in 3 parts, that is 2:3:1, then it will be 2, 3 and 1 only. So the first part will actually be 2 microcoulomb, the second part will actually be 3 microcoulomb, and the third part will actually be 1 microcoulomb simply. And hence we can just say that all these 3 capacitors will have this charge of 2 microcoulomb, 3 microcoulomb and 1 microcoulomb respectively. But we want to find out the charge on this 3 C capacitor. What we have to find out, charge on the upper capacitor. Upper मतलब 3C, correct है ना? तो 3C ये कैपेसिटर के अक्रॉस का जो चार्ज है तो वो कितना होगा, तो वो मैं समझ सकते हैं. That means it will be the middle one. ये middle, it will be actually 3 microcoulomb only. So 3 microcoulomb will be actually the charge on the upper capacitor of capacity 3C in this way here. That means option 1 is going to be the correct here. Yes, the same logic. Potential difference between each plates of the capacitors is going to be the same. So 1 is the correct option. Very good, correct. So next one, an air capacitor with plates of area an air capacitor with plates of area 1 meter square and 0.01 meter apart is charged with 10⁻⁻⁶ coulombs of electricity. When the capacitor is submerged in an oil of relative permittivity 2, then the energy decreases by. Okay, so see, we have to find out the initial energy, then the final energy, and then we will get the loss. Okay, so first of all, let us try to find out the initial energy, how much it must be. So the initial energy of the capacitor must be half of Q square upon 2C. ये फॉर्मूला हम क्यों यूज कर रहे हैं, क्योंकि when the capacitor is submerged in the oil of relative permittivity 2, मतलब क्या कि ये जो कैपेसिटर है वो उसके बीच में पहले एयर था, यहाँ पे एयर था, तो तब का उसका जो कैपेसिटी है तो वो हम उसको बोल देंगे C सपोज. बट व्हेन द सेम कैपेसिटर इज जस्ट सबमर्ज्ड इन ऑयल ऑफ रिलेटिव परमिटिविटी 2, मतलब के इसका वैल्यू, के का वैल्यू 2 है यहाँ पे, तो जिसकी वजह से क्या होगा कि व्हेन द सेम कैपेसिटर इज सबमर्ज्ड इन ऑयल, the oil will just get sprayed in the two plates of the capacitor, and because of that the capacity of this capacitor will actually become 2C here. तो इस कैपेसिटर का जो कैपेसिटी है वो 2C बन जाएगा, 2C के बराबर बन जाएगा, क्योंकि के यहाँ पे 2 दिया हुआ है, और इसीलिए अगर उसका कैपेसिटी 2C बन गया लेकिन चार्ज ऑन द कैपेसिटर इज गोइंग टू बी द सेम, बिकॉज आफ्टर चार्जिंग it is disconnected from the battery. ऐसा कोई दिया नहीं है वहाँ पे, but it is understood that once it is charged by this amount of electricity, ये पूरा चार्ज इसके ऊपर फॉर्म हो गया, उसके बाद उसको डिस्कनेक्ट कर दिया हमने बैटरी से, जिसके कारण वो जब भी अब अगर सपोज वो डिस्कनेक्ट करने के बाद अगर वो ऑयल के अंदर अगर ट्रांसफर भी होगा, तभी भी उसके प्लेट्स के ऊपर जो चार्ज रखा है हमने वो सेम ही रहेगा. चार्ज विल नेवर increase or decrease, and that's why charge will remain the constant. So that's why we'll just try to use this formula for finding the initial energy, where the charge across the capacitor is actually going to be 10 raised to minus 6. इसका square अगर हम करेंगे, just forget about that, it is going to be constant whatever it may be, and this 2C, C is also going to be the value of capacitor in air. Okay, now let us try to find out the new energy when the capacitor is submerged into a liquid. So in that case this Q square will remain the same, and 2 times of C. C के बदले क्या आने वाला है यहाँ पे, ये 2C आने वाला है, because when the capacitor, the plates between the plates, the space in the plate between the capacitor is filled with the oil whose dielectric constant is given to be 2 here, then we can just get that this capacitance will just get increased by factor 2, and that's why its capacity will become 2C. So here we can just get that it will be 2C replaced here. That means U dash is actually going to be Q square upon 2 times of 1 by 2 times of Q square by 2C. But actually if we just see Q square by 2C is going to be U only. That means we can just say that this will be expressed as U by 2, which means that if U dash is going to be U by 2, means energy just becomes half. That means loss in energy is just half. Half means 50%. That means the 50% of energy will be lost, or it will decrease by. So energy will decrease by 50%. That is going to be the answer, which is already there in option 2 here. Okay, the same thing is done here. Okay, so let us stop this here. Okay, तो हमने इलेक्ट्रोस्टैटिक्स के ऊपर के कुछ एमसीक्यूज यहाँ पे हमने देखे. Let us do some more MCQs, and so what JEE मेंस के MCQs जो है, previous year के MCQs जो है वो हम करेंगे next time. अगर हो सके तो आप भी थोड़ा सा वर्कआउट करके रखना. If possible, just try these MCQs at home on your own. I hope all of you know how to find out these MCQs there.